Okay, so good morning. I'm starting the session. Today is the 18th session in this fast track control system lecture, and we are finding today's topic is first and second order RLC system. So, yesterday, Pranav, you were not there. We had started module 3. So, I told you that around 5 6 lectures I will take to complete this module 3. So, these two lectures actually I had to complete in one session. But yesterday's session got curtailed because I joined late. So today we will finish this first order topic at least, and if time permits, then we will go for second order RLC system. And in your network also, you have seen what is the step response of second order RLC system. Very frequently asked question, that is what is meant by second order step response. What are the four there are four different types of second order step response diagram. One is for zeta is equal to 0, that is called as undamped case. Zeta is in between 0 to 1, underdamped case. Zeta is equal to 1, that is critical damped, and zeta greater than 1, which is called overdamped case. So I think if time permits, we will give a very brief introduction to second order system step response, which is also called as a transient response. But first order RL and RC, okay, that response definitely we shall be able to cover today. So let us start with first order transient response. So yesterday we have done impulse response thing. So what is meant by impulse response? It was shown yesterday. So lecture is uploaded already. So you can find first order system impulse response in your Google Classroom. So that note. And now this is a note for RL circuit step response, and afterward there will come RC circuit step response. Whenever I am saying impulse response, at that time the input will be impulse. So yesterday's note, if you follow, the circuit is kind of a same for RL, okay, but the input has changed. Yesterday it was kind of an impulse input, so impulse input at t is equal to 0, so it was a arrow kind of thing at t is equal to 0. That means input was happening only at one instant, that is t is equal to 0. So actually if you see in signals and systems also, you have studied this very basic signal, most primitive signal we say as unit impulse. Unit impulse is having amplitude 1, so where it occurs at t is equal to 0. So Rutik, yesterday I had shown you that diagram. I think you have understood now what is meant by impulse, right?
Yes, sir.
So yesterday's diagram it was shown. So impulse happens at t is equal to 0. It's upward arrow kind of thing. Example of impulse input is just giving a punch to somebody, okay, or hitting a cricket ball or hitting a football. That means the contact between the force and the object. So I'm punching somebody. So the punch is going from my side to the person to whom I'm punching. So contact time is very less, and huge amount of pressure or force is getting transferred from the source to the destination only within a very small amount of contact time. Whenever I'm hitting a cricket ball for sixer, so the contact time between bat and ball is very small. Okay, so in a jerk, if you are lifting something, okay, a very big weight is there on the ground. In a jerk, you are lifting. So for jerk and lifting purpose and all those things, we are using DC series motor. You have to remember, and DC series motor is having that impulse kind of response. Lift, एक लिफ्ट में 10 जन घुसा हुआ है, तो इनिशियली द लिफ्ट हैज टू स्टार्ट, and then suddenly 10 people and their weight plus lift of the weight of the lift, it has to be raised in impulse. So that is a jerk kind of a thing. That is actually the example of impulse input. What is meant by step input? Suppose I'm pressing this part, I'm pressing one part of my hand with a constant force for a long time. So the pressure is there and I'm pressing something for a long time, okay. So I'm saying that I'm pressing with some, suppose unit of force is Newton, so with 1 Newton. So this pressure from my finger to this on another palm is for a long time, so I am continuously pressing it for 1 Newton. Then it looks like this, whatever I have shown here. Okay, this is actually a step. 230 volt you are connecting to the fan. Don't see the magnitude is 230 volt. Don't say it is 1 volt or something, but think it as a state 1. So as soon as I'm switching the fan on, then I'm actually giving 230 volt to the fan. So that is a state 1, and as long as the fan is running, how much is the input connected to the fan? It is 230 volt. So I'm not saying don't think of that current or voltage that is coming to the fan, that is sinusoidal, but I'm just asking you to understand the concept of supply given to the fan. Supply given to the fan means it is switched on and it is being kept in on state for long. Okay, so on means up and off means down. So you are turning the switch on at t is equal to 0. And now one very simple thing I will show you. If you see this input, okay, now I'll tell you the concept of 0 plus. Okay. Can you see the between the upward arrow and between the blue line unit step input, there is a small time, there is a small gap between the amplitude upward arrow, that is at t is equal to 0, and where the step input is starting. Between them there is a small gap. Is it visible? Check the input side, this upward arrow and this input, there is a small gap in between. Is it visible?
Yes, sir.
Pranav, is it visible?
Yes, sir.
Can you understand what is that? Okay, that thing is actually called as a propagation delay. The time you are switching the fan on, that is happening at t is equal to 0. So this y-axis, whatever upward arrow is shown, that is actually t is equal to 0. At that time you are switching, you are pressing the switch, but it is taking some time. So that electricity takes some time, though it is very small time, maybe in nanosecond or maybe in microsecond, but that time is there. That time is called as a propagation delay. So that time is taken, that switch is on. Switch is also having its own action time. So every human being is having an action time. Somebody asks me, suppose you and me, we both are there, some person comes and says stand up. So I will stand up maybe in half a second, but you will stand up in 1 second. So response time for every system is different. Okay, so response time for every switch is different. Then when I'm pressing the switch, that is actually t is equal to 0. And when the supply is going to the fan and fan is started, that gap is called as 0 plus. So I have written here, I have shown it big, I have made it bigger because I am showing here what is this waveform is called as unit step. Why it is called unit step? Because it is a into ut. Ut is generally called as unit step, and a into ut. A is the amplitude. If I say it's a 5 volt dc, in that case a value will be 5. So 5 volt DC is actually 5 into unit step. So in that case, A will be 5. In this case, we are saying is we are trying to find out the unit step input response for RL circuit. Okay, so you can see here right side, there is a RL circuit and the switch is closed at t is equal to 0, and after that this unit step input will go into the R and L and something will happen in the circuit. What will happen in the circuit? We will see. That response actually we are supposed to find out. But very important thing is to understand what is unit step. So unit step is a input amplitude what you are connecting and you are turning it on at t is equal to 0. But can you find out what is the amplitude? Amplitude is a is equal to 1. So you can see that this blue line is going up to 1, but this is not going up to 1 at t is equal to 0, but this is going up to 1 at t is equal to 0 plus. So whatever is the gap between this upward arrow and between this unit step, this time is called as 0 plus. It is very, 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 very small time, maybe micro, maybe nanosecond or something, but it is there, we cannot ignore it. Okay, that's why we are saying that amplitude is equal to 1 from t is equal to 0 plus, and between 0 and 0 plus, what do we call that? That time is called as a propagation delay. And up to t is equal to infinity, so you are keeping the fan on, okay, and you are pressing this, you are giving this 1 Newton force to the surface for long time, up to t is equal to infinity. पूरा जिंदगी भर तुम ऐसा पकड़ के रहो. Okay, that means I am connecting this force, so I am connecting this supply to the fan, or I am pressing my one surface for long time. So this is the definition of unit step. So actually I am teaching you signals and systems also at the same time. So amplitude A is equal to 1 from t is equal to 0 plus. 0 नहीं बोल रहे हम, okay, because 0 में we are not getting the output, we are getting at 0 plus, and up to t is equal to infinity. For all other time, amplitude is equal to 0. What is the other time? In the negative time. So time t is equal to 0 up to minus infinity. There is no amplitude. So this signal is actually called as a causal signal. Okay, so I think you have studied this causal, non-causal, anti-causal, all those things you have studied in signals and systems. So what is called as causal? Causal is always in the right hand side. It starts at 0 and goes to the past. So this right side is t is equal to 0 is present, and this right side thing is delayed. That means this is the past thing that we are talking about. Okay, and left side time negative means it is actually the future thing. We are not talking about that. So it is a causal signal because it goes from 0 and up to goes to positive infinity. That means there can be delay. Okay. So this is actually about unit step input. And now, what if this unit step input is given to a RL circuit? Then what kind of response we are going to get from the RL circuit? That is our topic of discussions today. Okay, so I took almost 10 to 12 minutes just to explain what is the step input, because that is important. And in step input, again, you have to say that A into UT. This is the standard definition or standard mathematical expression of step input. Now, if I say 10 volt unit step, then A is equal to 10. Unit step, that means A is equal to 1. 5 volt DC, that means 5 into UT. So that is the way we have to represent it. So initially, we are giving a unit step input to the circuit. And so this Vs is 5 into Ut, or Vs is equal to Ut. Initially we are saying that RL circuit step input response, that means unit step input response, also called as RL transient response. Okay, so as soon as you are giving this kind of thing, sudden there is a jerk and you are going up and you are staying there. So slowly you could increase the output from 0 to 1 in a ramp kind of thing. So that is called as ramp waveform. But here you are not doing that. You are suddenly you are giving a jerk to the circuit, and that amplitude you are sustaining. So if you are giving sudden a jerk to the circuit, then how does the circuit components react to it? Okay, that is we are supposed to find out in this response. Yesterday we had seen step response, and we had found that as soon as you are connecting some impulse input to the circuit, and after that you are disconnecting it, and then you are finding that that current actually falls. In case of RL impulse response, the current was falling, and the current was falling with a function of L by R. L by R is called as a time constant. Now time constant is smaller, the exponential fall will be faster. Okay, and time constant is bigger, the exponential fall will be in a very it will take quite a lot of time to come to zero. So that was the impulse response. So Pranav, you were not there yesterday, so please check the note, because those questions will be asked in the final exam. Either impulse response, that is called also called as a natural response, or this is called as a step response, which is also called as a transient response. So there are two circuits, RL and RC. Both are first order circuit. Why first order? Because RL means there is only one inductor, one energy storing element. That's what is first order. RC circuit is also a first order circuit because C is a energy storing element. Hence RC is a first order circuit. So RL and RC circuit, I can ask you both impulse response and step response. So RL circuit step response, RC circuit step response. RL circuit impulse response, RC circuit impulse response. So all the four things can be asked. Proof we will not ask. Proof of the derivation and all these things we will not ask. But yes, the final equation, that is whenever we are doing RL circuit. So RL circuit initial current, when you just disconnected the supply from the circuit, suppose initial current was I0. Okay, now this I0 current will fall in an exponential manner and will come to 0. That is natural response, I told you. And what is the equation? I0 into e raised to minus RT divided by L. Okay, so this is we have seen. For RC circuit, what was the impulse response? We have seen initially the voltage was V0. So V0 is called as initial voltage, and that V0 will fall and come to 0. Okay, and how will it fall? Exponentially. And what was the equation? V0 into e raised to minus t divided by RC. And difference between RL response and RC response, look wise they are kind of same, but whenever we are talking about RL circuit, we will say that I'm all this talking about the natural response, yesterday's lecture. Whenever it is RL circuit, we said that it is the current which falls to 0. Okay, and in case of RC circuit, we see that the voltage across capacitor falls to 0. So RL circuit current falls to 0 exponentially, RC circuit voltage falls to 0 exponentially. And very big difference between RL and RC, that is another question, that is I can ask you the difference between RL and RC impulse response, or RL and RC step response. So for RL we found that time constant was L by R. Okay, so if R was increasing, time constant was decreasing, system fall was becoming faster. Okay, but for RC circuit, time constant is given by R into C. So more is the value of R, more is the time constant, system fall is becoming slower. Okay, so these two time constants we have to always remember for all LR circuit, for all RC circuit, time constant is L by R and RC respectively. Okay, so this is the difference. For inductive resistive circuit LR, the R value is actually inversely proportional to time constant. And for RC circuit, the R value is directly proportional to time constant. And time constant and system fastness, they are inversely proportional. So more is the time constant, system will become slower, and fast is the time small is the time constant, system will become faster. So with all this pre understood notions, we will now go for, that was all about impulse response or natural response. Now let us find out transient response. So these are different names. Impulse response is called as natural response, and step response is called as a transient response. So whatever is given in this notes, you can do that. And at the end of this note, I have given you all the codes also in MATLAB. So all the MATLAB outputs also have generated. You can check that. And in exam, you have to draw the standard outputs and also derivation proof we are not asking. But yes, that equation, final equation of output is required. Okay, so what is this thing? This thing is, we are giving a step input to the circuit, and the input is connected, but input is not connected to R and L because switch is open. Now at t is equal to 0, I am closing the switch. As soon as I am closing the switch, immediately the supply is not connected to R and L. It takes some time, 0 plus. So after 0 plus time, the current is, or the supply is connected to R and L. Okay, now there is a assumption. There is an assumption that this inductor was holding some current from the beginning. Okay, so whenever the switch was open, we could not say that inductor current is 0. Inductor was holding some current in beginning, that is called as I0. Okay, so all these things is going to help you in signals and systems. All this funda is going to help you in networking. So in networking also, there is a chapter called as transient response, and students are very much scared about that. There is nothing to get scared about. The switch is open. Okay, input is connected here, but switch is open. That means this input, that is the step input, is not getting connected to R and L. Okay, and we are assuming that the inductor is storing some charge, because inductor and capacitor is storing some charge. Whenever we are doing RC circuit, we will assume that the capacitor is holding some voltage, and that we will call as V0. Okay, so this another thing you have to remember whenever we are talking about RL circuit, it is all about current. Okay, so current is the output parameter for RL circuit, and whenever you are talking about RC circuit, it is all about voltage. So output parameter for RC circuit is voltage. That's why whenever we are doing RL circuit, we are assuming that initial condition is current, and that current is called as IL0 minus. IL0 minus means just before connecting the switch at t is equal to 0. So that current is called as IL0 minus. What is IL0 plus? Just after connecting the switch. Connecting the switch means supply is connected to the circuit components R and L. So just before connecting the switch, just after connecting the switch, the initial current stored in inductor is I0, capital I0. This is the assumption. And if you are saying that capital I0 is 0, in that case it is called as initially relaxed condition. Okay, so whenever all the initial conditions are 0, it is called as initially relaxed condition. But we can generate graph for initial condition 0. We can generate graph for initial condition non-zero. And this I0 value is very small actually. I0 value can be 2 milliampere. Actually 2 milliampere is a very big current in electronics. Okay, so I0 value is generally very small. Okay, these are the previously defined things, or these are the assumptions. I am actually talking more, but these things are not that difficult. Only thing is you have to see the input, you have to see the circuit, you have to tell the condition is before connecting the switch, there was a current stored in the inductor which is called as I0, which is called as initial current. Now we are interested in finding that at t greater than 0, that means after you have connected the switch, after this input voltage is connected to L and R, what happens to the circuit current? So initially the current was I small 0, which is a very small current. After we are connecting this unit step to this circuit at t is equal to 0, then how does the circuit current increases or decreases or remains constant? That we are supposed to find out, and that thing will be called as a transient response or step input response of RL circuit with input as unit step. So that is what written here. Step voltage input is given to the RL circuit. Okay, and we are interested in finding out current IT. So IT is nothing but the circulating current, whatever is current building up in the circuit, that is called as IT at time t greater than 0. That means after connecting the switch, after quite a long time, how much is the circuit current becoming, that we are supposed to find out. Now, inductor is having a very typical property, okay, that we have to understand. So if you're having pen and paper, you can write down that when just the switch is closed, at that time inductor behaves as an open circuit. Okay, just so, and after quite long time the switch is closed, the inductor actually behaves as a short circuit. And this is actually, you are connecting a DC. Okay, step input is kind of a DC, and whenever you are talking about DC, frequency is zero, because you can see the input. Okay, input is actually zero frequency. Zero frequency means f is equal to zero. Now there is something called as a XL is equal to 2 pi FL, which is called as a inductive reactance. And if f is equal to 0, inductive reactance become equal to 0. Okay, that means when this DC is connected to this inductor for quite a lot of time, after long time, what you will find is this inductor will behave as a short circuit. So there will not be any voltage drop across the inductor. So it is shown below. Okay, so just when the inductor is at t is equal to 0, that means just when the switch is connected, inductor behaves as a open circuit. And what is the initial current in the inductor? That is equal to I0. That means just when the switch is being connected, inductor acts as a ideal current source. Okay, so ideal current source is having internal impedance as infinity, and ideal current source is having a current. And how much is that current? It is initial current I0. That's why this diagram is very important. Okay, so more than control system, all these concepts you have studied in networking. Okay, so just when the switch is closed at t is equal to 0, inductor behaves as an open circuit, and there is an initial current in inductor as I0. That's why you are finding that circulating current in the circuit is I0. Okay, so this is at t is equal to 0. That's why it is called as I0. And now this input step is connected to the circuit. What will happen slowly is the current will start building in the circuit. Okay, so this explanation you have to write. So you have to listen to my lecture. So this lecture I'll upload because Vinay is not here. So you can listen to this lecture again afterwards, and you can write these explanations in your own way. So what will happen is, initially I've just connected. How much is the circuit current? Circuit current is I0. From where that I0 comes, it is assumption that initially the inductor was storing the current I0. Okay, and now when the input is connected for longer period of time, now this current will build up, okay, in the circuit, because because this inductor now will start behaving like a short circuit. Short circuit means very less impedance. Short circuit means zero impedance. So how much will be the current in that circuit in that case? So supply is Vs, resistance is R. So current I infinity will be Vs divided by R. That is called as a steady state current. So initial current was I0. I0 can be 0. Okay, not necessarily that I0 has to be something 2 milliampere. I0 can be 0. So if initial current is 0, then what we are saying is the inductor current initially is 0. Just assume I0 is 0. Then the current will start building up from 0 at t is equal to 0, and then current will increase, and then after a certain time it will get saturated. And what will be the saturated current at I infinity? It will be Vs divided by R. So this is actually the characteristic. It is an increasing kind of a characteristic at infinite time. That means when the supply is connected for quite a longer period of time, we will say that steady state indicate inductor acts as a short circuit. So at steady state, what is meant by steady state? Very important thing, because there is a steady state error finding in this case. We have to see. Steady state means t is equal to infinity. Transient means t is equal to 0. So when just switch is connected, that state is called as transient state. And switch is connected for long amount of time, after 5 minutes, 10 minutes, okay, after infinite seconds, that is called a steady state. So initially, as soon as you are connecting the switch, circuit में थोड़ा ऐसे ऊपर नीचे ऊपर circuit थरथरा जाता है. Okay, something ऊपर नीचे and all those thing happens. And then after that, the current starts building, and finally the current gets set at a final current. What is the final value of current? You are finding it is Vs, resistance is R, inductor is working as a short circuit, right? Because at t is equal to infinity, inductor works as a short circuit. So this is Vs divided by R. That is the steady state value. And you can find out here that I infinity is equal to Vs by R. So initial current is I0, and final current is actually Vs by R, something like that. So what is the final formula? Final formula is Vs by R plus I naught minus Vs by R into e raised to minus RT by L. So this you have to remember, because initial current was I0. Okay, if this initial current I0 is equal to 0, then you will be finding is it is Vs by R minus Vs by R into e raised to minus RT by L. And what is L by R? L by R is called as a time constant for RL circuit. So this equation you have to remember. So if there is non-zero initial condition, that means initially there is 2 milliampere or 3 milliampere or some current, that value is this I0. Vs, I suppose, say unit step, that means Vs is equal to 1. R value, suppose I give you, chalo R 5 ohm le lo. Okay, so this is actually 5. And inductor L, take it 2 Henry. So I can ask you, tell me the equation of IT. So if I say 5 volt unit step, if I say unit step, that means Vs is equal to 1. R value should be given to you. R value, let's say 5 ohm. I0 initial current also should be given to you. That means let's say 2 milliampere, and Vs by R. So Vs is 1, R is equal to 5. So Vs by R is 0.2, and e raised to minus RT by L. So L का कुछ value देंगे. So I can give you all these values and I can ask you, write the equation of IT. Okay, just you have to do, keep on substituting the values, and you have to give me what is the equation of IT. Only thing is Vs is the amplitude of step. If I say 10 volt DC, in that case Vs will be 10. If I say 5 volt DC, that means Vs will be 5. If I say unit step, Vs will be 1. Okay, so I think this is very much possible. And the plot of IT. Okay, so IT we have just seen Vs by R plus I0 minus Vs by R into e raised to minus RT by L. How will it look like? So now you can see here, so this all graphs are generated by using MATLAB. So here you are finding that this red line is the inductive voltage actually, which is in the circuit. Okay, and what is the blue line? And blue line is a graph for RL step response. So you are finding that inductive current and inductive voltage. So you will be finding that inductive current is increasing. The red one is current, and the blue one is voltage, because the inductor impedance is reducing and voltage is directly proportional to impedance. Initially, I told you that inductor will be open circuit. That means all the voltage will come at across the inductor. So how much is that? Very big voltage. And as time goes by, from t is equal to 0, you are going up to t is equal to infinity. As time goes by, the inductor becomes short circuit. And what is the voltage across short circuit? Voltage is 0. So that's why you are finding that inductive voltage is falling exponentially and it is coming to 0. And as inductive impedance is reducing, that means overall circuit impedance is reducing. That means the current in the circuit will build up. So that's what I've shown you, that if initial current is 0, from 0, the RL circuit, overall circuit current will increase, and it will go up to a certain value. This value is actually Vs by R. Okay, so in this case, suppose Vs is equal to 1 volt, R is equal to 1 ohm. So that's why Vs by R is equal to 1 by 1, that is 1 ampere. So what we are finding is current is starting building up from 0, because initial current we have assumed 0, and it is building up and it is getting stable, steady state. Okay, so is it understandable, Vinay? Are you seeing? So Vinay is not there. Rutik, is it understandable?
Yes, sir.
Okay, Pranav.
Yes, sir.
So if you're having pen and paper, just दो line लिख के लो. Okay, in this case, 0 to 5, this region is called as transient region. और समझ लो तो भी चलेगा 0 to 5, बिकॉज 0 to 5 में करंट जो है दैट इज एक्चुअली बिल्डिंग अप. तो करंट चेंज हो रहा है, हलचल हो रहा है. एज सुन एज यू जॉइंट GIT, द इनिशियल डेज फॉर 1 or 2 months, तुमको ये नहीं पता था कैंटीन कहाँ पे, किसके पास जाना है, ऑफिस किधर है, who is HOD, how to proceed, and all those things. So as soon as there is some energy introduced in the system, you are switching on, you are connecting the unit step at t is equal to 0. That means you are introducing some energy in the circuit. As soon as you are introducing some energy in the circuit, circuit thoda halchal hota hai. Okay, so from 0 to 5 seconds, if you see this graph, okay, the current is increasing. So this part is called as transient part. So when you join GIT or any college, initial वो 2-3 month जो रहता है, तुमको ये नहीं पता, वो नहीं पता, ये हो रहा है, rule पता नहीं. So because you are a new agent in the overall system, so you are in a transient. As soon as you will be joining a new job, first 1 to 3 months, it will be a transient period for you in that company. And after that, जब तुमको rule सब पता हो गया, then you are set. Okay, then you know how to do, what to get. So this 0 to 5 seconds, this is what I'm asking you to write down in this graph. This note also I will upload shortly. So the 0 to 5, यहाँ पे देखो current is increasing. Okay, और voltage is also decreasing. Not necessary transient में हमेशा increase ही होगा. It can increase, it can decrease, doesn't matter. So there is a change. Okay, so there is a change. So 0 to 5 is called as a transient region, and 5 to 30 or 5 to infinity, what is that thing called as? That thing is called as steady state. Why steady state? Because you can see that the current is not changing. It has gone up to Vs by R. Amplitude, current amplitude has gone to Vs by R, and it is steady. Okay, so at steady state, whenever the system response, that output of the system enters steady state, it does not change its value anymore. वो वहाँ पे रह जाता है steady. Okay, but if you see 0 to 5, there was a lot of change. So all the increment, decrement in the current voltage, this and that happens in the transient region. So if I ask you, so this is a 0 to 30-second response, system response, RL circuit response of current. What is the transient region and what is the steady state region? The answer will be 0 to 5 second is the transient region. Why it is transient region? Because in this case, current is building up, voltage is reducing, and all those things are happening. After 5 seconds, what happens? Current reaches to a fixed value, it stays there. Voltage also comes to zero across inductor, it stays there. So it is written here, inductive current red and inductive voltage blue graphs. Okay, so this top graph, तुम बोलोगे सर वोल्टेज और करंट तुम एक ग्राफ में कैसे दिखा रहे हो? Technically speaking दिखा नहीं सकते, but in MATLAB we are just plotting functions. Okay, and if we see how the voltage is reducing with increase in the current, that means actually your impedance is reducing. So initially the impedance is very high, because I told you as soon as you are connecting T is equal to 0, the inductive impedance is equal to infinity. When impedance is equal to infinity, current is 0. So that's why initial current is 0. As a time going by, inductor is showing or becoming a short circuit. So slowly the inductor impedance is reducing. Slowly means it is reducing exponentially. That's why inductor voltage is also reducing exponentially, and inductor current is increasing exponentially. Okay, so this is above what is given as the transient response and steady state response for inductive current and inductive voltage. Now below is given resistive voltage. Now resistive voltage is equal to R into IL. So if the current builds up, if IL is building up, R into IL will also build up. So whatever is the graph of IL, okay, the red graph, uska jo curvature, uska jo slope and all these things, you will be finding that below resistance का भी resistive voltage का graph curvature वही रहेगा, because red graph is for IL, it is changing. 0 to 5 is transient, 5 to 30 is steady state. Below it is called as RL or VRL, because VRL is equal to R into IL. R is a constant. Okay, that's why you just multiply IL with R, what you are getting is VRL. And this graph and the red graph and black graph, they are actually exactly identical looking. And 0 to 5 is also again transient, and 5 onwards it is steady state. But one very important thing in this case, so these two graphs, if you are drawing, it is enough. One very important thing is, in this case, I0 is equal to 0. That is one thing you have to see, because we are starting from initial current, I0 is equal to 0. अभी कुछ graph दिखाएंगे where I0 is non-zero. Okay, so okay, and now another three things. This three graphs, okay, you are finding red, blue and black. अब ये बताओ which graph is fast and which graph is slow. What is meant by fast? Which graph is reaching steady state fast? Which color? And which color graph is reaching steady state slow? I want your answer. I'm waiting. I have shown you three responses. Which graph is reaching to output fast, steady state fast, and which
Red,
graph
sir.
is red is reaching fast. Thank you, Rutik. Okay, so you're finding that red is reaching this thing very fast. That means what? That means iska time constant kam hai. That you have to understand. That means R value for red graph is high. What is the time constant for RL circuit? It is L by R. So if R value is high, time constant is low. If time constant is low, means it will reach to the required output very fast. So in this case, very important thing is there. I have shown you actually three system. You can say that तीनों का inductor value same है. L value is let's 1 Henry. But for this red graph, R value is very high. For this blue graph, R value is medium. For this black graph, R value is very small. Okay, exactly the same kind of thing I had shown you last day. Okay, so you can say here the red is very fast, blue is medium, and the black is very slow. Okay, so RL response with different time constant, initially zero point 0.3 ampere. Now, again, another thing you have to see here. So I think it is understandable. So यहाँ पे लिखा नहीं है कुछ, but you can understand. So red will be high value of R, and black will be less value of R, because time constant is L by R, and smaller is the time constant, faster is the rise. Bigger is the R value, smaller is the time constant, faster is the rise. ये एक line लिख के रख सकते हो. For this graph, bigger is the R value, smaller is the time constant, and fast will be the rise. Okay, and but what is the starting current here? It is starting from current 0. And what is the final current? Final current is 2 ampere. अभी देखो, if starting current is non-zero, now we have set starting current as zero point 0.3 ampere. Okay, so all these things you can set in the MATLAB code. You can set any kind of thing. So just see that starting current is zero point 0.3, and it is going to the same steady state value. If you see the previous graph, okay, it was going to the same steady state value around zero point 0.5 ampere. If you see here, the red is steady state current value is zero point 0.5 ampere. Here also it will go maximum to zero point 0.5 ampere, but here it is starting from zero point 0.3 because it is zero point 0.3 ampere. And the blue graph, if you see the previous case, blue graph steady state value is 1 ampere. You can see the left side steady state value is 1 ampere, and red black one is having steady state amplitude as 2 ampere. Below also the blue is going to 1 ampere, the black is going to 2 ampere. Okay, but initial current starting point is different. Okay, so I'm going to show you two graphs together. Okay, अभी ऊपर वाला ग्राफ और नीचे वाला ग्राफ. Is it understandable that the top graph, which was having I0 as 0, it is starting from 0 and then building up. Okay, but below graph, the starting current is zero point 0.3 ampere. So it is starting at 0.3 and going and getting steady up to 0.5. Rutik, is it understood? Just see the starting point.
Yes, sir.
Just see the starting point. Is it understood? What is the effect of I0?
Yes, sir.
Clear, na? Okay, and somebody will say, sir, I0 can be negative. वो भी हो सकता है, negative current. So that also I have plotted. What I am taking is I0 is equal to minus zero point 0.4 ampere. Okay, so steady state value is same. You can see here steady state value for red will be 0.5. Previous case also it was 0.5, but now it is building up from 0.4. So initial current can be the value and magnitude, both can be adjusted. So second blue was having 1, third black was having 2, but it is now building up from zero point 0.4 minus to 1. Okay, so in this case there is a quite a lot of transient region in this case whenever there is a negative current, but blue is starting from minus zero point 0.4 and going up to 1. Black is starting from minus zero point 0.4 and then going up to 2. Okay, so this is very important thing. And then below all the discussion is given. Smaller is the time constant tau. Okay, तो L by R को हम लोग tau बोलते हैं. Smaller is the time constant tau. Faster is the rise in inductive current response. I told you. Okay, and Rutik also found it out that the red one is fastest. That means red one जो system है उसका L तीनों का same है, but red का R जो है वो सबसे ज़्यादा रहेगा. Because L by R we are supposed to find. More is the value of R, less will be L by R, faster will be the response. The same thing is written here. तो तुमको भी थियरी में आंसर में यही लिखना है. You have to draw these three graphs. You take initial condition, some value. From there you show three graphs and say that L is constant. But if R is more, tau is less, system will reach to the steady state faster. So as tau is equal to L by R, hence the higher values of R, the time constant measured at 0.6321. ये फंडा बाद में बोलेंगे. From where this 0.6321 comes, okay, will be lesser. So time constant will be lesser. And system will be faster for constant L. It means that system output will reach to final value of input a step faster in time. Okay, so more is the value of R, less will be the time constant, and system will reach to the final value faster. This was actually called as the transient response of RL circuit. Same kind of response will be there for transient response of RC circuit, but in that case we will be talking about capacitive voltage. What is the parameter here? It is written here in the y-axis, RL step response current amplitude. In this case, you are talking about the circuit current or inductive current that actually is building up. Now let us see what happens for RC circuit step voltage response. Okay, the same input is given, the same step input is given to circuit RC circuit. Okay, now in this case at t is equal to 0, the circuit is not connected, and sorry, t is equal to 0 minus circuit is not connected. Now I am connecting the supply to the circuit at t is equal to 0, and voltage starts building up at t is equal to 0 plus. And there is another assumption that initially this capacitor is capacitor C farad, and it is storing some voltage, and that voltage is called as capital V0. I think my notes is visible to you. So it is called as capital V0. So शुरू से वो कैपेसिटर थोड़ा वोल्टेज स्टोर करके बैठा है. How much is that voltage? Can be 2 millivolt or maybe 3 millivolt or 0.5 volt. Some voltage it is storing. And that voltage can be zero also. So we will treat initial voltage as V0. Okay, and V0 can be zero, V0 can be negative. Like previous case also you have seen that initial current can be negative. Okay, and initial current can be positive also, but it is very small. Whatever it is very small. ऐसा कभी होगा नहीं कि inductor is storing 10 ampere current as initial current, or capacitor is storing. Yes, capacitor can store big voltage, 2-4 volt it can store, but generally inductive current stored is smaller. Okay, anyway, so whatever is the value, we are not thinking about that, we just are treating that initial voltage is V0. So this is the situation. First you have to explain the situation, and then you have to start explaining the response. So what we are doing is actually we are doing transient response. What is meant by transient response? Input connected to the circuit is step. If is A into ut, if A is equal to 1, we call it as unit step. If I say 5 volt DC, means 5 into ut, likewise. So we are actually going to see how the voltage builds up in the capacitor. So output is taken across capacitor. Capacitor is C farad, Vt is the output, Vs is the input. We are going to plot Vt. Previous case what we had plotted was IT or ILT or IRT, because it is a series circuit, so there is only one current in the circuit. So consider a series RC circuit connected to a voltage source like this. At t is equal to 0, the switch is connected and the voltage starts building up from t is equal to 0 plus. And 0 to 0 plus, that time is called as a propagation delay. That you have to remember. That switch is pressed and supply starts building up. उसके बीच में एक time gap है, which is shown here in this image also. That time is called as propagation time or propagation delay. Assume that initial voltage V0 on the capacitor. We are interested in finding out Vt. Vt means changing voltage with respect to time. Okay, so we are interested in find out Vt across the capacitor t greater than 0 plus. So t is equal to 0 is initial transient, t greater than 0 or t is equal to infinity is called as steady state. That means how the capacitor voltage is going to build up and how is it going to reach to the final amplitude of 1, that we are going to find out. So proof is given. Proof you are not supposed to see, you can only see the final result. So what will be the equation of Vt? Vt will be, so this is the equation you can remember. Vt is equal to Vs. Vs is the supply voltage. So if you are giving unit step, Vs is equal to 1 plus V0. What is V0? Initially stored voltage in the capacitor, maybe 0.2 volt. Okay, so Vs is unit step means 1. V0 is initially stored voltage 0.2. Okay, and Vs is again 1 e raised to minus t by tau. Now in case of RC circuit, tau is equal to R into C. So what all things I should give you? I should give you the Vs value. I should tell you what is the input. If I say it's a 5 volt DC, Vs is 5. You should know how much is the V naught. If not given, you can assume V naught 0.2, 0.1 volt or something. Vs is equal to 5 volt and e raised to minus t by tau. So t you can change. So if I ask you, chalo 5 second बाद output voltage कितना है? In that case, t you can substitute at 5 seconds. So t is a function of time. कौन सा time में तुमको output चाहिए? That t value you can substitute here. Okay, and tau is equal to R into C. Okay, so R into C value should be given to you. So at any instant, I give you this circuit, I give you the value of Vs, V0, R and C, and I can ask you to find out the output at any instant. 10 second में find करो how much will be the output. So you have to substitute t is equal to 0 and all other four values is known to you. You can tell me how much is the time. Now if v0 is equal to 0, okay, this is an ideal case or this is a subset case of the whole thing. If initial voltage is 0, okay, then vs plus 0 minus, that means the whole equation will become vs into 1 minus e raised to minus t by tau. Tau is equal to rc, so we will not call tau, we will call rc. So if initial voltage is 0, in that case, what will be the equation of small vt? Small vt is called as instantaneous voltage. It is vs into 1 minus e raised to minus t by tau. ये पूरा प्रूफ देखना नहीं है तुमको, सिर्फ ये एक ही इक्वेशन देखना है. Which equation? You can remember, this is page number 3. You have to see only this equation. Okay, that is vt is equal to vs plus v0 into vs into e raised to minus t by tau, and tau is equal to r into c. That's all. Okay, and all these proofs and all these things will not be asked, so don't worry. And then we are going to plot it. Okay, so if you are going to plotting it, exactly the same thing you will find, but in this case the changes I will tell you. Changes: red is the capacitive voltage, okay, and the blue is the capacitive current. What was the property of inductor? Inductor actually, at transient time, at t is equal to 0, inductor was open circuit, and as time goes by, inductor is short circuited. Capacitor का पूरा उल्टा है. When at t is equal to 0, capacitor acts as a short circuit, and as the time goes by, the capacitor becomes open circuited. Okay, so open circuit के across voltage बढ़ता रहता है, and open circuit के across current कम होता रहता है. And exactly opposite in case of inductor. Inductor was initially open, that's why current was very less, and then it was getting short. That means current in the inductor was building up. Capacitor का उल्टा है. Capacitor initially was short circuited. So how much is the voltage? You can see this red graph is the capacitive. It is capacitive voltage is red and capacitive current is blue. Be very careful. Previously, the red was current and blue was voltage in case of inductor. In case of capacitor, red is voltage and blue is current. Okay, so current and voltage graph swap ho gaya. So previous case, the current was building in case of RL circuit. For RC circuit, the voltage is building. Initially, how much is the voltage? Initially, voltage is 0. किसके अक्रॉस वोल्टेज जीरो होता है? शॉर्ट सर्किट के अक्रॉस वोल्टेज जीरो होता है. दैट मीन्स इनिशियली द कैपेसिटर is acting as a short circuit. As time goes by, because we are connecting here a DC voltage, and DC voltage for capacitor is kind of a high impedance thing. Okay, that's why the impedance becomes open, or a capacitor acts as open circuit. Because here initially the current is initially the voltage is very less, because impedance of the capacitor is 0, and as the time goes by, impedance is becoming open circuit and the voltage reaches to the peak. And how much is this voltage? If you are giving input as 5 volt, this voltage also will be equal to 5 volt. That means capacitor initial voltage will be very small, V0 or something. V0 can be 0, you can start here. So in this case, initial voltage is 0. As time goes by, the capacitor will start building up voltage. That means that across both the plate of the capacitor, plus and minus charges, they will keep on arranging each other. So top plate जो है वो पूरा positive हो जाएगा, bottom plate जो है it will be all negative. They cannot recombine because capacitance is offering an infinite impedance to this path of flow of positive and negative ions, and all the positives will get stored in the top, all the negatives will get stored in the bottom, and there will be a huge potential difference between the top and bottom plate of the capacitor, and capacitor will show a very high voltage of 1 volt, because 1 volt is the input we have given. Okay, and below you are finding that this is the current across resistor. This you are finding. So circuit current is also falling. Why circuit current is falling? Because capacitance impedance is increasing. Initially capacitance impedance was 0, circuit resistance was only R. As the time is going by, the impedance of the circuit is increasing, and at t is equal to infinite, in circuit impedance is equal to infinite. That means circuit current will become 0. So that's why this blue line, this is the capacitive current or circuit current. It is starting at high value, but as time goes by, it is falling to 0. Resistive current is also falling to 0. Okay, so this black and blue line, so current in the circuit and resistive voltage, they will be following each other in an exact manner. Okay, and capacitive voltage and capacitive current, they are ulta. Capacitive voltage in this case is increasing, and capacitive current in this case is decreasing, and after 5 seconds the current has come to the steady state. So in this case also 0 to 5 is the transient state. What is meant by transient? जहाँ पे amplitude change होते रहते हैं. Let us say voltage, let us say current. Okay, so between 0 to 5 वो voltage और current में हलचल हो रहा है. And after 5 seconds the voltage becomes steady, that is amplitude 1. Current becomes steady, that is 0, and the circuit will enter a steady state. So 0 to 5 is called as a transient state where all the amplitude, voltage and currents are changing. 5 to 30 is called as a steady state where current and voltage has become steady. And only thing you have to see here is the initial voltage is 0. So the capacitor voltage has started building up from t is equal to 0, and then it is going up to 1 at steady state. Now somebody says, sir, comparison chahiye. Now here I have shown three graphs. Okay, black, blue, and red. Just tell me which case the waveform is faster, black, blue, or red, and which case the waveform is slower. So this is actually the capacitor voltage buildup. Black, blue, or red, which voltage is reaching to the steady state fastest? Black. Very good, Rutik. So in this case, black voltage is reaching to the steady state fastest. That means time constant in black is actually small. And what is time constant of RC circuit? C constant रखो. तीनों यहाँ पे तीनों सिस्टम दिखाया है, तीनों का C constant रखो. So for the black R value is small, for the blue R value is medium, and for red R value is big. So previous case RL circuit it was reverse, but RC circuit, more is the value of R, more is the value of time constant, more will be the time taken for the waveform to go to the steady state. Steady state मतलब क्या? ये देखो black जो है almost after 3 seconds it is reaching to the peak. We have given 1 volt input to the circuit. That means capacitor output will reach to 1 volt. But how fast it is reaching that 1 volt? That is actually if it is reaches to 1 volt very fast, that means transient state is small. So we want system to be like this. We want all the student to get set to GIT very fast. Transition time should be very less, transient should be very less. Okay, so faster you can reach to the steady state, better for the system. So in this case black is reaching to the steady state very fast. That means time constant for black, this system is very small. That means R value for black is very small. So ये दोनों चीज बहुत इंपॉर्टेंट है फॉर इंडक्टिव RL circuit. Time constant is inversely proportional to R. Okay, and in case of RC circuit, time constant is directly proportional to R. This is a very important thing. So in this case, as black is faster, that means R is small for black, R is big for red. One more important thing is you have to check it is also starting the voltage build up from 0 amplitude. Okay, so in this case V0, that is the initial voltage, is equal to 0. We have almost finished, 2 more graphs and I will stop. What is the initial voltage in this case? Can you tell me? Initial voltage is positive or negative? And how much is the initial voltage? This graph. Just see the graph, it is all written there. Just see what is the point from which the voltage has started building up. What is the initial voltage in this case? For all the three graphs, initial voltage is same. How much is that? Y-axis dekho, where is the graph starting from? How much is the voltage? Is it 0 or it is 0.7?
0.7, sir. 0.7, sir.
Is it understandable? So it is not starting from 0. Just see the bottom part of the previous graph. It was starting from 0. Okay. Because in this case V0 was 0 and it was going up to 1. So final value is same. Final value cannot exceed 1 because input we have connected is unit step. So capacitor will go up to 1 volt only. 1 volt cross करके ऊपर नहीं जा सकता है. Okay. So in this case, the below case, the voltage, initial voltage is 0.7. So how much is the travel part? It is only traveling for 0.3 volt. So it is in starting at 0.7 and going up to 1. So how much is the traveling part? Traveling part is only 0.3. But this top graph, how much is the traveling part? How much is the traveling part for the voltage? It is going from 0 to 1. So traveling part is 1 volt. But for this below graph, traveling part is 0.7 to 1. So travel has become smaller. Okay, so in this case system will reach to the steady state very fast, but in this case also you are finding that black is fastest and red is slowest. Last graph, we will keep a negative initial voltage. So how much is the initial voltage in this case? Initial voltage in this case is minus zero point 0.4 volt. So how much is the travel here for all the graphs? They are all starting at minus 4 and going up to 1. Okay, so what is the total travel between positive and negative, or high and low? It is 1 minus of minus zero point 0.4. So here the travel is 1.4 volt, though the final voltage across the capacitor will be equal to 1 volt, but that 1 volt is building up from minus zero point 0.4. It is not building up from 0, because initial voltage in this case we are assuming as minus zero point 0.4. Okay, so this is how the V0 thing is changing the look of the graph. But everything said and done, black is the fastest and red is the slowest. So last four lines I will read. Smaller is the time constant tau, faster is the rise of the voltage. As tau is equal to R into C, the lower the value of R, time constant will be lower. And if time constant is lower, system response will be faster. It means that system output will reach to the final value of the input. So final value input, if you are connecting 5 volt, the capacitor final voltage will be 5 volt. Okay, in that case we are saying steady state error is equal to 0. So that is the another concept I'm telling you. I'm connecting 1 volt and all the capacitors are reaching 1 volt only. In that case, how much is the steady state error? Input minus steady state value, 0. Both are output is 1. But if somehow there is a defect in the capacitor, okay, so though I am connecting 1 volt, but capacitor is not reaching to 1 volt, capacitor might reach to zero point 0.8 volt. Okay, so input I am connecting 1, but capacitor output is saturating, or steady state value is zero point 0.8. How much is the distance? 1 minus zero point 0.8, that is 0.2 volt. What is that error called? That error is called as a steady state error. So next day we will do the second order RL transient response, and after that we will start with steady state error. So from this diagram only you can understand what is steady state error. This black is supposed to go to 1. Why? Because input connected is 1 and capacitor voltage should be same as input voltage. But if for some defect in the capacitor, the output voltage cannot go to 1, output is getting saturated at 0 0.8. So it should go to 1 ideally, but it is getting saturated at 0 0.8. So 1 minus 0 0.8, 0 0.2 is called as a steady state error. And uska bhi analysis hai. Okay, we will do that. So this was all things for today. Again, we are pressing on the same point, that is for RL circuit. The resistance is inversely proportional to the time constant, and for RC circuit, the time constant is directly proportional to the resistor, provided L and C both are constant. Now these are the codes which have helped me to generate all these graphs. So if you just go through the code, it is not difficult to understand. It can help you. Okay, any system you are designing, first order system and all. So I'll be posting these codes also, and I'll be posting this theory also. So what can be the question? Two 10-mark question I have already done. First question done yesterday. Explain the natural response of RL circuit and RC circuit. So you have to write the equation, graph for both. Today we have done another 10-mark question. Explain the step response of RL circuit and RC circuit. So RL circuit 5 mark ke liye, RC circuit 5 mark ke liye. So for 5 marks, what all you can say? First, you have to tell what is meant by step response. Then you have to draw the circuit. So step you have to draw, circuit you have to draw. Then you have to say what is the working of the circuit. Ek line equation, bas what is the output equation with initial condition. Okay, so with I0, and for RC circuit with V0, and you have to draw those 3 graphs. एक ब्लैक रेड एंड ब्लू वट एवर, एंड जस्ट शो अ कंपैरिजन कि आर बढ़ता है तो क्या होता है, आर कम होता है तो क्या होता है. And if you have time, you can show the effect of initial voltage or initial current. That if we are assuming initial current as suppose 0.3, the graph changes from 0.3 up to initial final voltage. And also you can explain what is meant by transient part and what is meant by steady state part. So one very important thing I would like to tell you, if it is asked for 5 marks, maximum you can write is 1.5 page. इसका मतलब ये नहीं है तुम बड़ा बड़ा हैंड राइटिंग करके somehow you will fill 1.5 page. No, नॉर्मल राइटिंग फॉर 5 मार्क्स मैक्सिमम यू हैव टू राइट 1.5 पेज, उससे ज़्यादा नहीं लिखना है कितना भी बड़ा क्वेश्चन हो जाए. एंड इफ इट इज़ अ 10 मार्क क्वेश्चन, मैक्सिमम यू कैन राइट 3 पेज. 3 पेज मीन्स एक पेज का 1 2 एंड अदर पेज का और एक. Okay, so your all diagrams, all graph, all circuits, all inputs with all diagrams, जबरदस्ती बड़ा नहीं draw करना है. Okay, so this is a rule that I have set, and remember that. And if you check the proportion with your booklet that is given to you for writing, उसमें भी यही प्रोपोर्शन में, टाइम के साथ, मार्क्स के साथ यही प्रोपोर्शन में सेट होता है. सो फॉर 5 मार्क्स 1.5 पेज, फॉर 10 मार्क्स मैक्सिमम 3 पेज. तुम लोग क्या करते हो, जो आता है उस पर 10 पेज लिखते हो, और नेक्स्ट क्वेश्चन 10 मार्क्स यू हैव रिटन 2 पेजेस. वैसा नहीं करना है. ऑल क्वेश्चन, इफ इट इज 10 मार्क्स क्वेश्चन, मैक्सिमम 3 पेज. सो एक पेज का बोथ साइड और दूसरा पेज का हाफ. And if it is one 5 marks question, 1.5 page. And best possible theory, best possible information you have to compact within this 1.5 page. जबरदस्ती भरो मत, जो आता है उसको अच्छे से अरेंज करो within 1.5 page and do that. Okay, so thanks for joining. I will upload